and YouTube should be on as well. But I only follow comments from Twitch. If I did stuff correctly, yeah, I set up some Twitter bot, just testing it today, and I see that indeed it posted Errichto is now live on Twitch. Check it out here. I won't necessarily keep this bot, I just wanted to see if it works. Same in Discord. Yeah, it seems to work. Oh, that is not an interesting message. I will need to set it up better next time. Highlight some. Hi, Desher Boja. What is it? Difficult nickname, Ravish. Hi, hi, hi. Did I solve bubble cap questions? No. I heard that there were a lot of technical issues. So even if I had time, and I don't remember if I had time, even if I was bored or something, I wouldn't solve those problems because they were not good. Yeah. Consider joining the Discord server. We have already more than 1000 members. That's some quick growing server. Interview questions on binary search. Yeah, that and Leetcode. Somebody suggested tree and graph problems. Maybe this is a good thing to focus on. I will start by looking at this all problems list. One good list of problems is, how is that called? Blind curated 75. Yeah, this thing. So this list of 74 problems, just like the title suggests, is, I think, a list of very common problems that you should know. And maybe I will every week do 2 or 3 of them. But also I'm going to see what this is. Top 100 liked already saw, but what is top interview questions? And Leetcode curated algo 170. Because I heard from Alex Weiss that all of that is kind of stupid. It's not really good quality, but maybe curated is good. But what would that mean? Oh, does curated mean locked behind paywall? Then it's out of the way, I guess. Well, it's very convenient to have a list of 200 problems that I should ignore or just avoid. What do I have here? Top interview questions. Basic calculator 2. I don't think this is a top interview question. Sliding window maximum. Okay, but most of them are well-known problems. So is it most of the first 100 list? Oh, I see. It's just that this is sorted by likes or something like that, and no new problem is here. Half of this is just very old problems. First, problems are numbered in Leetcode by time of creation, and I see that half of these problems in this list are with numbers from 1 to 100. Now we have problems of ID 1500. Oh yeah, and if I didn't mess up things, there should be now a Twitch bot thanking for follows. So indeed, thank you, for example, Stealth HS. I don't want to bother and read all of that during the stream. Instead, I prefer to provide a quality explanation of solution of a problem, but be aware that I am welcome for following. What did I say? I am welcome. You're welcome. I am thankful for you following me. Otherwise, I wouldn't do the streams. My Leetcode profile pic rotated 90 degrees. Oh yeah, because they have such a feature. If I go to settings, there is an option to rotate. I don't know why they created such a feature, but hey, I used it. Okay, so I assume that those lists are bad, and this is the only one that is good. And I will experiment with homework problems for you, because every week, Thursday, we meet for coding interviews on this evening. I can as well, at the end of the stream, point to two problems that you should solve as a homework, and I will start the next lesson from describing them. Maybe it's a good idea to just get those problems from this good list. Like the first week, it will be just these two. The disadvantage of this is that I think like first 20 problems here at least are very well known, and they will be boring for a lot of people. Nice homework. Please don't give hard problems. Everybody will be dissatisfied with some difficulty. Easy problems. We can see what's the feedback and how many people solve this problem indeed. But yeah, let's do something. Can you please do clone graph on Leetcode? You can see what it is. This right side is for drawings. Given a reference of a node in a connected and directed graph, return a deep copy clone of the graph. This is a little bit language dependent, so not really good thing for me for an algorithm lecture. This is language knowledge, not an algorithm skill. I can talk about like what I think should be done, and that's it. We will not go into coding. We're given a graph by pointer to one of the nodes. Then what I need to do is I need to create a new thing. So in some way create here a new pointer, new object. Copy the value, because there is here, we create a new thing with the same value. Like that. Let's say this is what we can do. At the end we will return a pointer to this node. But also I need to run through neighbors of that node, and each of them also copy. In order to know if somebody is already copied or not, maybe I would use a map or an ordered map. So what about a map from old pointer to new pointer? Now whenever in DFS I enter some vertex, that my logic will be, if this vertex is already copied, then do nothing. Otherwise, create a new vertex using constructor or using new. I think it must be using new, so that the structure wouldn't be run later. So here I should use something with new. And then I should remember that we have this mapping of old pointer was 750, new pointer is 7000. Then map 750 into 7000 and go through the list of old neighbors and run DFS for each of them, so that this DFS would return. Okay, so this function, I will not have any extra helper function. I will just have this. I iterate over node neighbor in what? Node neighbors. And here we will do I want clone graph of this neighbor to return something. So what do we do? My new neighbors dot pushback of that guy. And this is how I create new neighbors. And at the very first line we do if map contains node, then return map of node, map of this pointer. This is pseudocode for the solution. And unless there are questions, I will now move on to something more algorithmic. This is just, half of this problem is language knowledge. I will not solve code forces problems today. First day is for Leetcode and binary search. Generally, first day is coding interviews. Saturdays are for code forces. Can we have a Discord bot for homework? Why do you want a bot? Is there any advantage to bot over any kind of announcement? Also, I can maybe in Discord server, I can create a channel to put their links to homework. I don't know. Would that be good? But I don't see a reason for a bot. Thanks, man, you're the best. You're welcome. Kind of leaderboard. But then I would need to play with some API, right, to know who solved what. I don't even know if Leetcode has API. Does it? Codeforces does. For Codeforces, so what I will do for Saturdays, I know that this is off topic, but I will just create a gym, and or mashup contest? No, just gym, it can be public. And every week, can we see something here? Every week I would, let's say, insert 2 new problems here, and the next Saturday we would talk about those 2 problems. Difficulty would be like medium-ish. Yeah, I don't know, 1500 or something, 2000. Okay, so this will be convenient in Codeforces. For Leetcode, I'm not aware of any such mashup possibility, so that I would add problems to some list and you would solve it there within that list, and I would see who solved what. But yeah, what's also possible for me with this homework is that I would review some random codes from the audience. Like I would grab this code and I would say, yeah, do this differently, this is ugly copy paste, this is a stupid unnecessary variable, stuff like that. Let's really make educational lessons out of those Thursdays and Saturdays. Any language to solve the problems? Of course, but I understand Python, Java, and C++. I will likely, and if something works, then I will understand basically any common language. If something doesn't work and needs debugging, then that's another thing. We will talk about rules once I start this thing. Okay? Just today, at the end of the stream, I will choose some 2 homework problems, and next week we'll see how it goes. No fixed rules now. Okay. Latest weekly hard problem related to bits. Minimum 1 bit operations to make integer 0. Skip. Oh, this is a good one. What, the one suggested by Dush? I see William Lin in YouTube chat. Just for your information, I mainly follow Twitch chat. Lower quality is available, but only on YouTube. Okay, I will take a look at this. Given an integer n, you must transform it into 0 using the following operations n number of times. change the rightmost bit in the minor representation. I didn't understand from the first try, but if people don't complain in the chat, then sure, let's do this. If you want to grab the statement as well, you can Google the problem title, or you can use the command link, which I'm preparing right now, and done. Yeah, it works. Well, let's try to understand what they said in the statement. Change the rightmost thing. So if there is a sequence of bits, I can flip the state of this bit, I guess from 0 to 1, or if it was 1, then I would change to 0. Or change the ith bit I guess looking from the right. So change this. This is I. If the previous one, looking from the right, is set to 1, so now this is impossible. But here change this thing. If this is 1, this must be 1, and all of this must be 0. Is that right? Return minimum number of operations. Okay, so we kind of go from right to left and we try to get rid of every next bit. Okay, what happens if there are already quite a few zeros? I hope I didn't misunderstood. We need Errichto command. I don't know what that would do. Oh, I have an idea actually. Yeah, I will do that after this problem. If we have zeros and there is a 1 here, then to change this I need 2 operations. I will first change this 0 into 1. No, I cannot. Oh. If this is the input string, then I need to change this to 1. This will be easier in their editor. Oh, the editor is here. Why is it not consistent? That's the title if everybody needs that. And I'm not increasing the font. Okay. If we have this, then I need to change the last bit. Then thanks to it, I can change this one. Then this and so on. I can eventually make everything to be equal to 1, I guess. And then I can keep changing from the left. Regarding spoilers, yeah, if you see that I'm trying to solve the problem from the very beginning, if you know a solution for sure, then don't spoil the whole thing. You can share your own thoughts. You need to have zeros from I-2 to 0. Oh, yeah, I cannot just make the suffix with ones. What needs to happen is now I need to change this to 0. Okay, so that's a different thing. Then change this to 1, change this. Thanks to that you can change second bit. Then you can change this. Then you can change this, and so on. So we very slowly grow, and I can understand what's the cost of moving from this state, where the second last bit is 1, to this state. Here I used 4 operations. Maybe in general it's like 8 operations. The previous state was here, so it's not always here we use just 1 operation. No. Actually, we have this, and only then I can remove this. So maybe it will be always a power of 2. Okay. Now, is it always true that I aim to get rid of the rightmost one? If the input string is like this, then is it true that I need to in some way get to this one? Well, I cannot modify anything here because this is 1. What I could do is change this into 1. Like immediately, I can do that. I can move from here to there. You will more often during the streams just see me explaining the problem, but sometimes the problem is non-trivial, and then you will see me solve it, and that's when you can learn the process of just analyzing with some test what needs to be done. Because it's not that here I apply sorting or something. I need to understand what is that optimal strategy, how I minimize the number of moves to get to the final thing. If limits were very small, but they are not, if limits were very small, then this could be treated as a graph problem. Then I could say that every number is a vertex, and I can make some operations, so there are some edges to other vertices, and I'm looking for the shortest path towards vertex 0. But usually limits aren't very, very small. Usually we need to analyze something, we need to understand stuff. Okay, so I have a choice between doing this, or maybe, and then I have a choice between, oh, actually, is there any sense for this other than to in a moment remove this bit? Okay, interesting. I would say that always after changing 0 to 1, if the next bit is 1, the next operation should be to get rid of this 1, because what else can I do from here? If I look at this string, I can do some stuff in the suffix, but the only goal of that would be to populate this suffix. No, I will get rid of this one. So I have this. Okay, in one step I get this, and this way I move 1 by 1 to the left. But in order to get rid of this one, I obviously need a lot of operations, and that will likely be a power of 2, I'm guessing. Maybe it's not true. Okay, now I see. Eventually, this one will get to the position next to the other one, and then that other one can be cancelled. and we can keep moving. Now let's focus on the number of moves to move between these two. Or because I will not touch the prefix, let's just focus on this. What is the number of moves to get from this string to this one? Or just what's the answer if the input is this number? Yep. What can I do? I can do something with the suffix, but my goal is to get 11000, this thing. Then I will be able to do this. And there are two steps here. There is step of moving from this suffix to this one, and there is step of moving from this suffix to this one. So I can say that kind of cost of length L will be cost of length L minus 1 plus cost of length L minus 1, maybe plus 1. Plus 1 comes from doing the operation from here to here. Okay? Then there is some number of moves in this part and in this one. But I don't really do the same operation in those two steps. Here I want to change suffix from zeros to 1 and zeros. Then the other way, from 1 zeros to zeros. Okay, and this is defined, let's say, as cost of L, but what about that? What do I need to do to change from zeros to 1? To get rid of this thing, I need to get to this state, something, and then 1, 1, 0, 0, this. This character doesn't matter. Then get rid of that. Okay, in order to get from here to there, I need to first get this. So I need to get 1 on that third position. Then I am able to change this bit. And then I need to get rid of this bit. Okay, now done. Why William is not making any videos since last month, even after winning IOI? Maybe now he doesn't care about fame anymore. He got the ultimate fame. I don't know. But he has enough time to play games on my Twitch channel, Among Us, sometimes during the weekend. Okay, so is this now easy? Let's try to sum this up. But I don't like the problem. I like algorithmic problems more rather than just staring at binary sequences and analyzing them. Let's make this a bit shorter to make it easier to work with. So in order to get rid of 1 on this position, maybe it will be cost remove of L. It means cost to remove 1 on this position L is equal to, I need to create on the previous position plus single operation from here to there plus cost remove of L minus 1. This is to get from this string to this one. Okay, now cost create of position L is this is whatever I analyzed here. I need to first, to create on this position, I need to create the previous position plus make a single operation and then get rid of that next thing. So from this we get that cost remove to and create is the same. Also maybe I could just say that they are symmetrical in some way. Is it? Why is there the same cost to get rid of this one? Why to get from here to there. This is the same total cost as to get from the final thing to the initial one. Well, that's because those operations are symmetrical. If I can make an operation, like flipping the last bit, the rightmost bit, I can also simulate this from the end. I can also flip. And this requires the suffix to be 1 and zeros, and then flip this next bit, but then also I can reverse it. So cost of getting from state A to state B is the same as getting from B to A. I could finish this analysis much quicker and just know that cost create and cost remove is the same. Also, cost remove of position 0 is cost create of position 0 is just 1 to modify the very last bit. So bit number 0 if we count from the right. Easier to think from zeros to 1, 0, 0? Maybe. These are symmetrical. But yeah, we already understood that cost. Did not understand why they are the same. And that's because for every 2 bits, for every 2 numbers, the fact I can move from this number, I can move from this to, let's say, that in one move by flipping this bit. So there is edge from this vertex to this vertex, and in the minimum number of steps we want to get to some final vertex. But I can also say that then from this string it's possible to get to this one in one move. We just apply the same operation. We flip this bit back. We can flip a bit if and only if the remaining suffix is of form 1 and zeros. So if a moment ago it was possible to flip this bit because the suffix is good, it's of form 1 and zeros, then in a moment it's again good. This, and we can flip this back. So moving from one number to another means that we can also move from another to the first one. So it's not just some directed graph that from A to B you can get easier than from B to A. And this means that from zeros to get to 1 and zeros, it's the same difficulty as from 1s to zeros. Yes, it's a reversible process, as Gupta says. Okay, so I can just say that cost of 0 is 1, cost of I is twice cost of I minus 1 plus 1. So the cost will be 1, and then twice this plus 1, so 3, and so on. Those are powers of 2 minus 1. But does it match what I wrote here? Oh yeah, because here I investigated what's the cost of moving 1 to the left. And that's something different. Like moving 1, 2, 3, 4. Let's see. 1, 2, and 4. Something is wrong. Oh, 1, 2, 3, 4, 5, 6, 7. Okay, it's fine. From zeros, I analyzed before that indeed to create a 1 here, I need 7 steps. That's 1, 2, and so on up to 7. So everything is alright. This is a sequence saying what is the cost to create some bit at some position or remove it. And now, is the problem easy? What we need to do if we are given a number. But here it might be easy to mess this up and to say that's something we're doing. Yeah, let's analyze. To do anything with the prefix, I need to first, I could get rid of this 1 and put a 1 here, but this seems like a lot of work, because to create a 1 here, a process of creating a 1 somewhere, it's about slowly shifting with one moved from the right. So not only this is what I need. So this cost of creating and removing of I is 2 to I plus 1. Yep. But also there is something like cost shift. And this will be cost to shift one from position I to position I plus 1. And this will be, well, like that. To move from 0 to 1, there is cost of 2, then cost of 4, and so on. So I'm guessing that this is 2 to I, and I will define this as cost to shift from position I minus 1 to position I. For example, from position I minus 1 to position I equal to 2, the cost is 4. And in particular, to create, let's see how this makes sense. I wrote something stupid here. This is power of 2 minus 1. Let's see. Cost of 0 is 1, then we have 3, 5, and so on. Does this work? 2 to third power minus 1. Yes, now it works. The previous formula was stupid. And we can check if these two formulas agree with each other. In order to create 1 on some position, I will first create 1 on the very last position, and then we'll shift it by 1 to the left, by 1 to the left, and so on. That's the process we saw here. So we can say that cost of creating something on position 5, it's actually 1, cost of getting the very last bit to be 1 from 0, then cost shift of 1 plus cost shift of 2 plus and so on plus cost shift of 5. And indeed, such a sum of powers of 2, like 1 plus 2 plus 4 plus 8 plus 16, the sum of that will be the next power of 2 minus 1. So everything is alright with our formulas. Now that this is out of the way, let's get back to looking at this. I think the strategy will be to move this one to the left by 1, then by 1, then eventually we will get here. And the cost of this shift is just sum of powers of 2. Now the next, I'm able to compute this cost. No. Then I can remove this thing. Then I can continue moving with 1 to the left. Or should I maybe just remove this one if possible, get rid of it, and then do something here. Get rid of this, then you can get rid of this. So the strategy would be, if the next one is single, there is nothing nearby, there is no adjacent other one, then I need to get someone towards it so that I could be able to I could remove that one. Like if this is the initial situation, to get to this one, to get rid of this in some way, I need to shift this one to the left. But if this was the situation, then I would say that instead I remove this one, I change it to 0. And then I immediately remove this thing. So go from right to left, keep track of the rightmost one, always find the next rightmost one, like here. And the strategy is, if this next position doesn't have a neighboring one, then move this one towards it in order to destroy this one. Otherwise, destroy this thing and then get rid of this neighbor. But I have no idea if this is optimal. Maybe some other interpretation of what's going on here. Given a number, I can change the last bit, or if something has 100 at the end, I can flip that even next thing. I don't know. What if you think about going from 0 to the number? You need to get the highest bit in any case. Okay, I can try that. That's a good suggestion. So let's grab some goal number, target value, because we already know that this process is kind of symmetrical, it's reversible. We can say that this is the final goal. I start from zeros. Then, in order to create this last one, I need to get to this situation. And only then I will be able to do this, and I can continue. So, I can say that I need to create this thing. It doesn't matter that there is something here. It's only important that the leftmost position I need is this. Then I say, I create the one on the next position. Only then I'm able to create something here. That's the first moment when I get something here. I know the number of steps needed. And then I continue with this suffix. It's just that I already have a 1. And maybe I can remove it, or maybe I need to shift to the right. In this case, this is already here. This seems easier, but still I would say it's easy to make a mistake. Shift all ones to the right and then remove the rightmost and repeat. What are you talking about? Shift all ones to the right and then remove the rightmost and repeat? Well, it's not that in this problem we are able to divide the whole number by 2. Ravish, I don't know what you're saying. It's apparently some famous code. I saw already somebody mentioning gray code. I will look it up. To get rid of a single bit, I indeed described how I can shift to the right, and I described the costs. But it isn't necessarily optimal to go do that separately for every bit. You said shift all ones to the right. I don't shift all ones to the right simultaneously. Okay, so here I'm sure that first it's good to do this. Then we have this string, and now I need to decide whether I want to if 1 is there in the final string, so that's the target. Then I need to decide whether I'm leaving this one. I think that will be optimal. And then let's just focus on the problem of given starting from 0, let's try to create this. Or what happens if this is 0? Then I would say that we just shift this one to the right. And that has some cost. I will do that to the next one. Is that fine? I know the cost of shifting from this position to this one, and then we will run for this remaining part. And so on. Let's summarize. Let's summarize what my solution is, what I think it is, but maybe I should grab some sample test. 9. Yeah, let's do 9. Let's see if I can create a correct output. If this is the target, and I start from 0, 0, 0, then first I want to create this one. and I know the cost for that, because the cost of creating on position I, this is 0, 1, 2, and 3. This is 2 to 4th power minus 1, that's 15. And then I do something. Oh, that's already too much. This is 14. Okay, then I can say that this problem defeated me. I want to see the standings. People solved it in around 10 minutes. Under 1 minute? Well, I don't see here anybody solving in under 1 minute. Even if you know something, it takes a moment to read the statement and to find it online. But if it's something well known, then for sure it's bad to use it during any contest. Check inverse gray code. Don't I want some fun from coming up with that myself? No, I meant you solved above DP problem in 1 minute. Oh, okay, sorry. I read your comment out of context. I will give this one final try. The thing is that when creating this one, oh, I see. Just before the first moment when this one is created, I have this. And this uses 7 steps. Then I get to this string, so that's +1. And then I shift this one to the right by 2. Shifting like this costs 4 + 2. And then I will get my 1001. So my solution was fine. It's just that I don't create directly that last bit, I mean the leftmost bit. It's I create this bit +1, then I do say that this is changed and something happens. Well, I would feel bad not implementing this now, also because I don't know if my solution is correct, so I will try. There is number n. I will make an if for 0. But otherwise, always find the rightmost bit. Should I first create a string? Okay. Now, bits of 0, for example, gives us the rightmost 0, the rightmost bit. Bits of 3 gives us bit at index 3 looking from the right. Grab size, the length of this vector, and now if len is, for example, 5, then it means the leftmost bit it's on position 4. And I said that if I want to create something, I want to start by saying create on this position, and what I do is I create on the previous position, then I make this extra step. So cost of creating on this position +1 because I need to move then from this string to this, And then I have this unnecessary one. So I need to say if bits of len minus 2, because I can here assert that bits of len minus 1 is true. This is the leftmost bit, it must be 1. If this, then skip this bit, if this is in the solution. Otherwise, I need to get rid of this bit or shift it to the right. Yep, easy enough. The answer fits in int? I think it should. Let's get rid of this if. I think I don't need it. Not bits empty. If not bits back, then pop back. Otherwise, we have a 1 at the very end. Answer increased by this. In particular, I already changed like that. I have this unnecessary 1 on this position. Well, position greater or equals 0 and not bits of position. Surplus equal cost of shift and position minus minus. Okay, then eventually either position is minus 1, then we got to the end of the string, or maybe we got to some bit and we say, okay, we got this bit set and let's move on. This means that if on position 5 I created a bit and indeed it should be there, then just move on to the remaining 5 bits in the suffix. Okay, I need some functions. Cost of position. This is cost of removing or erasing. It was 2 to I plus 1 minus 1. And this is just 2 to position. Guys, what's the probability that this will work? I really didn't expect that. I didn't expect spending 1 hour at the beginning of the stream on one problem. Maybe not 1 hour, but for sure it was like 40 minutes or something. Popback is wrong because it's bits.popback. 50%, 90%, 99.9. You know, if you're saying 90%, then I could bet against you. Your answer, expected answer. Who would have thought? Okay, the code turned out easy. But I will need to read the editorial. Check the code of first rank. I see. I understand bitwise operations, so it isn't magic to me. I see what is going on. We grab n, we XOR it with answer, and then by dividing by 2, we shift binary representation of n by 1, and so on and so on. it means that every one in n, it is kind of replicated to every next position. So I can, understanding this code, I can also say that this will work. For ans is 0, for every position of a bit, let's say up to 40, more is not needed. If n and this, then I say replicate this one all the way. Right? Yeah, I can submit this again. Should get accepted. For example, if n is 1010, then this one, it will affect the answer on this position, this, and this. This one, it does that. And I just got, apparently I created something equivalent, but so much more complicated. Then what do we need to do? We need to read the editorial. Also, this I will comment out because it's not really my solution. How to get to editorial of something like this? Who suggested this difficult problem? Why did you want to watch me struggle? This was supposed to be an easy stream. No editorial. Okay, I can read this in a moment, but also, what was that called? Reverse gray code? So no, this is not the same with our algorithm. I thought that from this we get that. Oh, maybe from the right part we get left. Is that correct? Yes. So reverse gray, it means that if we get gray code in the input and we need to find binary number returning that. Constructing an n-bit gray code. There is some algorithm. Oh, here we go. Converting to end from gray code. You can just copy this. This is exactly the solution, gray to binary. This is exactly the solution we saw in the leaderboard. Oh no, it was me? Well, douche, then what can I do? Like, I cannot not ban you, right? That would be immoral to allow you to still watch the stream and comment and give suggestions. Do I want to now understand everything about this? Also, how is this problem created? Is this change the rightmost bit and switch between 0, 1 and 1, 1? How many operations we need? I wonder. The only reason I can see for this being gray codes is something like that, like this way we iterate increasingly through gray codes or something. So it's equivalent to saying that 6 is the 4th. No, that's stupid. I was thinking about something like, maybe if we write down all possible binary numbers one by one, and maybe if we also write down all possible codes that are described here, reflected binary codes or gray codes. Yeah, let's try that. Note such that two consecutive values differ in only one bit. Author wanted to test your Googling skill. I bet that after I understand this enough, I will just see that this is exactly the definition of something described here. I don't see it yet, okay? Because here they describe some operations. But I bet that this operation is really mentioned here in some way. There's nice DP solution. I also thought for a moment about some dynamic programming on bits. Save VMK got a nice DP solution. Okay. I think that this is quite similar to my solution, or not. BO. If solution for n is already computed, then return it. Otherwise, here he basically this is basically to propagate everyone to the right. Oh, but with OR, not with XOR. Minus equal this. Okay, this is a strange way to find the most significant bit. Then he subtracts it. And he says that he wants to create a 1. This is always run for a power of 2. So that will be very easy, I guess. In my solution, this was just cost. This was basically my function cost. He could here just type cost of the length, binary length of ls. What is smaller, smaller equal? Oh, I don't know. Shift without sign. Okay. I didn't know this operator. Why would people cheat in this and how? They didn't really cheat. You are allowed to use the internet. But also during online contests, a lot of people try to use at least oeis.org. And if you know solutions for small n, let's say there is some problem about DP with stairs and you realize that the first answers are 1, 2, 3, 5, 8, and 13, you hit enter and you will find a formula for this sequence. And the website told me that this is the beginning of Fibonacci sequence and this is the formula to compute every next number. But this also works for more complicated stuff, including our gray codes. Do they have here a list? I want to just grab 5 first numbers in decimal representation and then plug it over there. I don't see it. I'm too lazy to convert it from binary. Interesting but sad. Just organizers should be aware of that. But Leetcode isn't that competitive platform. It's mainly about preparing for coding interviews, so then they shouldn't really worry too much about that. If they want to prepare people for coding interviews, then it's up to every person if they want to participate competitively, and then they should indeed use the internet if they want a nice place. Search OEIS for this. Decimal equivalent of gray code for n. Okay, cool. Please change the problem. That's a very good suggestion. Need to transfer it. Okay. Well, this is similar, let's say, to what I analyzed. This will be just summary. I will not do it now. I don't think it counts as an interview problem. Yeah, it will not likely be asked in an interview. Maybe from time to time, but if something is asked once every 1000 interviews, you shouldn't worry too much about it. My streams are great. Thank you. Thank you, Xcrush. Okay, let's close it. Let's close and forget about this problem. Douche, today no more suggestions from you. Let's for a change go to binarysearch.com, or actually that website has more difficult problems, doesn't it? Sorry, my bad. Don't worry. I think that from time to time we need something difficult. Did this solution work? Yes, my solution worked. I got accepted. Guys, do we do binary search or Leetcode? Alex Wise, how exactly do you pronounce your last name? Rice, Wies, Wise, Wiki? Leetcode, binary search. Yeah, let's do a quick voting. Just say Leetcode or binary search. Can be. BSIO also counts as binary search. But I'm still confused by what name I should use. They started as binarysearch.io. I think we're close to tying, but I see more Leetcodes. I don't really see repeated comments. The name is just BS. Yeah, but if I title my video or stream BS, nobody will understand that. Or also, the name binary search as a video title is confusing. Leetcode, yeah, okay, Leetcode. YouTube asks, what is binarysearch.com? It's a website, you can open it. Then, okay, and new question, easy or hard? Do we continue with a similar difficulty? Overlapping. Maximum XOR of two numbers in an array. That's boring. The medium. Hard. Easy speed run. This one problems C from the same contest. Well, then maybe it will not be about with the same style. What is this? They really need to compute? No. We are not doing this. Check this. All paths from source to a target from Great Coder. Given a directed acyclic graph, a DAG, find all possible paths from node 0 to node n-1. It's up to 15. The input graph is guaranteed to be a DAG. So because it's a DAG, the solution is limited by 2 to nth. It is backtracking. I wonder what's the point with this DAG thing and does it help? Isn't this just Ford Fulkerson? No. Is Ford Fulkerson to iterate over all paths? Let's work with this problem. I will put it in stream elements bot. Isn't that Floyd-Warshall? Guys, you need to understand what every algorithm does. Floyd-Warshall computes what it does. It computes shortest paths. Here, and you will not print here a shortest path. They ask you to print all the paths, not shortest. So it has nothing to do with all those algorithms that are there exactly to find the distance. That's APSP, all pair shortest paths. Yeah, so that's indeed acronym for what Floyd-Warshall computes. Okay, we will do this. I will start by doing backtrack and then I will think whether something smart is possible here. What we can also do here is find any traversal ordering from 0 to n-1 and then just iterate over bit masks, over subsets of vertices. We can try that as a fun extra exercise in a moment. But okay, we have edges. I want to know edges going out of every vertex. Iterate over things in graph. What's n size? We're not given n? Oh, graph of I is a list of all nodes you can visit from node I. Cool. I thought that is the standard Leetcode form of getting pairs of vertices, saying that there is edge from A to B, there is edge from C to D, and so on. N is 15, so it's about something exponential, can be a backtrack. I can prove, and later I will do it, I can prove why the number of paths in a DAG doesn't exceed 2 to n. This is needed to say why the output isn't huge. Because what if we are given a full graph, then there would be n factorial paths. Assuming that we don't want to repeat vertices. N factorial is the number of orderings of n vertices if there are all the edges. Can't we do DP in this problem? We can, it will be just a little bit faster backtrack. Later I will try to get another solution. First, a backtrack. All paths source target. First, let's just try to run DFS from 0. Let's pass graph. And let's gather in some answer. This is what I will return later. Every path I will put here. You need to pass here by reference if you want to make it fast, if you don't want to make a copy. DFS of this. If A is equal the final thing, but what is final thing? N is equal to answer.size, not to graph.size. So this is n-1. So this is the last vertex. If this, then answer.pushback something to return. Otherwise, if we are at some vertex A, we consider going to 1 or going to 2. We consider going to neighbors. This is already something. And what do we push back here? I need to push back a path. But then I need to have this path. And this, do I want to pass this by reference or do I want a copy? Let's make it fast. Let's pass it by reference. And I need to create it here in order to pass it. And now when I enter a vertex path.pushback A, but then after like a lot of iterations in different places of a graph, this path would only grow. So after moving back from a vertex, if I considered now everything going from this vertex forward, I retract my path. You can imagine a snake starting from vertex 0, and the snake he follows your trails. And then if you move from something to the next vertex, he follows along, and this is what path contains. But if you get back and you try another way, or not a snake, this is a rope. Imagine that this is a rope you have, and the rope is the way for you to get back to the start. That's, I think, a better analogy. Yeah, I think that's it. Let's try to run. Like other tour? Not really. Server error. That's unusual. Wrong answer. Output this, expected that. Maybe I don't pop back at some moment. Oh yeah, I see. I should pop back whenever I return from a function. So that's here as well. Let's see if it's better then. Oh, answer is correct. Yeah, because when I enter a vertex, I update my path from the start to my current position. But before exiting from this function, so before this return or before this moment, because this is also when I exit, I need path.popback. And submit. A DAG doesn't contain cycles. Correct. This means that I don't... Still, they could just give arbitrary graph in the input. That's suspicious. They could give arbitrary graph in the input. They could just say, find paths without repeated without repeated vertices. And then when trying to expand a path by the next vertex, you could just see if this vertex already exists in a path. If yes, then it's forbidden. What is the time complexity of this solution? An obvious limit for time complexity here is n factorial. N factorial would be the number of all possible orders of n vertices. Actually, this is the number of possible paths with all n vertices. You can add to that shorter paths, and so on. But just like with powers of 2, like if you write down 2 to nth power plus 2 to n minus 1 power plus and so on, and smaller powers, every next term here is much smaller than the previous one. Like the next term is n times smaller, the next term is even n times smaller, so you can just skip everything here. There is another combinatorics like explanation for what this sum is, but let's not worry about it. N factorial is the number of possible orderings of vertices, of n or fewer vertices. In a DAG though, not all orderings are possible. And I will argue that actually this is enough. Because every, how is it called, topological order? Okay, here's a proof. Every DAG has some topological order. This means, because there are no cycles, it is possible to reorder vertices in such a way, or just write down the order of vertices, so that there would be no edges back. No matter what graph I will draw, maybe I draw this graph, let's ignore numbers. Let's say that there are letters here. This is a DAG, this is a graph without cycles. It is possible to write down some order, like here it would be B, E, F, A, G, but there are a few more, such that edges only go to the right in this order. For example, there is edge from B to F, there is edge from F to A, also edge from F to G. If you want to understand this better, you need to read about topological order or topological sort. And the thing is, every path from start to the end, it will correspond to some subset of those vertices. And the number of subsets is only 2 to nth power. And we cannot shuffle them around. We cannot say that BFA is one path and BAF is the other path, because edges go only to the right. So this is the limit for the number of paths. How can I lower the quality? You can watch on YouTube. Go to this link and you can watch there. What quality? What a burn. Yep. No. How to solve this if it's only directed, not acyclic? Then the complexity will be n factorial, but there would need to be a condition that path cannot have repeated vertices. If there can be repeated vertices, then you can go forever in a cycle. But if the statement is find all paths without repeated vertices, then the same solution would work. Just additionally, we need to check if when going to a neighbor B, check if maybe it already exists in a path. And the complexity is then n factorial. I'm quite curious about the solution thing. I don't know if I can show it during a stream. I have second Leetcode account and I have a premium. I bought premium there. I guess I will log in to that one. And can they sue me for showing this in a stream? I saw other people doing it. Doesn't mean that then they cannot sue me. I'm just very curious about this. Sign in. So I will just show you that, yeah, I have here a premium. Here we go. The reason why I have two accounts is that I don't want to show something like unintentionally during a stream if it's not legal. Because now even if I intentionally click, I cannot see stuff. Okay, I'm looking at that on my second monitor. If you have premium, you can look at that too. Approach 1, backtracking. Sure, then it's just my solution. Yeah, it's the same thing. And is that it? Complexity analysis. They explain why it's 2 to nth power. Approach 2, top-down dynamic programming. This is the one I mentioned at the beginning that I would later implement it in another way. Oh, what am I moving? I changed something in OBS settings and I don't know what that is. Okay. Can you explain once more when we are pushing back? I can do some visualization. And that is, but you should start with a problem like, given a graph, find any path from start to end. That would be easier for you to implement. Again, not to worry about numbers. Let's say that graph contains letters. Actually, I like my previous graph. Let's say that here we start from B. When we are in the FS in B, then the current path should just contain B. Let's say that then from B we move to E. Then, when I'm at E, this is the current path, B, B, E. Then from E we move to some neighbor of E, right? We are at E, I go for neighbors of E, there is just one neighbor, I go to it. Then the current path is BEG. This is what I explained as a rope from the very beginning to our current position, how we got there. Then I'm out of neighbors. From G there is no other neighbor. So I retract my path. I go back through my own steps. I delete this, so I also pop back. Now I'm at E. If there was some other neighbor, like that, then I would now go to that other neighbor. But there is none, so I just get back even more. And now from B, I'm at B. The current path from the start to current vertex is just this, one element. Then I move from B to F. Path is that. I move from F to some neighbor, like G. Path is this. And you see, now it would be stupid to have E in our path, because right now I got to G via a sequence of vertices B, F, G. There is no E in that process. Later I will get back from G to F, and I will visit the other neighbor, A. And then the path will be BFA. More people are commenting on YouTube compared to Twitch. That's possible. But also I see that some don't use English. Okay, so I think it's now more clear what this path represents, and then also it should be understandable when we modify it. When we go to the next neighbor, we add this new vertex to a path, and when we are out of neighbors of a vertex, so we quit the FS from this vertex and we get back to the previous one, then that vertex we were at a moment ago, we need to pop it back from a path. So pushed back every single of those paths, right? Yeah, if G is the final cell, if I want to find paths ending at n-1, then what my solution does is the last element of path is A, the current vertex. If A is equal n-1, so this reads as if A is final vertex, the target vertex, then yes, to the answer, push back the path, the current path. So BFG would be pushed back if G is the final vertex n-1. Then this next line we do because I want to continue the FS from the previous vertex, from F. And the G is now not part of the path. Is there any limit on number of topo sorts? I don't really understand your question. We don't here do a topo sort. Maybe you ask, is there a limit for the number of different topological orders? And then I will say there can be a lot of them. Exponential number of them, 2 to n, if graph is connected, I think. Oh, actually, it's just n factorial. If you're asking about this part of the proof using topological order, then there can be a lot of them. Consider this graph A, and there are edges to B, to C, to D, and so on, to all the other vertices. Then those B, C, D, E, and so on They can be in any order with respect to each other. So there will be n-1 factorial possibilities to reorder them. So path is a stack. Yes, I should have said that indeed. A path you can think about as a stack. Vector in C++, it's kind of a stack. Just I could here use, instead of a vector, a stack, because I only pop back or push back. I never access some middle element. I used vector because they told me to return a vector of vectors. And then if I used stack instead, I would need to convert then stack to a vector. Ban this person from YouTube chat, he is abusing there. Well, if somebody doesn't know what I'm teaching, then he shouldn't watch. So one ordering has 2 to n paths, so what would be n factorial? Oh, I see. You're talking about my proof that I said there exists some topological order, and I said that every path corresponds to some subset, hence 2 to n. And the thing is, if you reorder them in a different way, the same subset must produce the same path. It cannot happen that you choose BFA and this is a path, and also BAF is a path. Because then, if there is edge from F to A and from A to F, there would be a cycle. One set of vertices can produce only one path in a topological graph, in directed acyclic graph. Otherwise, there would be a cycle. So, even though there can be a lot of topological orders, it's not that they produce different paths. They cannot, for this reason. Can I do this iteratively? Yes, we can. With memorization, I guess. What's a topological order? I will not explain it now. It's not really needed to implement a solution, but you can read more about it. Can we find the number of topological orders in polynomial time? I don't know. I guess that for a tree it's possible, for generally for a duck it's impossible. Okay, yeah, let's talk about some iterative solution now. What I did here is just I run DFS, and every time when I'm in DFS, I remember kind of stack of this DFS. Instead, I can do this. When I'm at 0, I see that I have some neighbors. Then I ask vertex 1, my neighbor, hey, what are paths from you to the final vertex? And I say that all those paths will be good plus myself. Let's just look at this. Let's say that there is 0, and from 0 there is edge from 1, and there is edge to, I don't know, 4. I don't care what is the rest of the graph here. It's something. Then I want to ask 1, hey, what is your set of paths to the end? And now I want 1 to tell me, 1 will tell me, oh, there is path 1, 5, 9. Also there is 1, 7, 6, and then 9. Those two. Okay, then I know from 0 there are paths like that if I prepend 0. Okay, so now those will be the paths from 0. this will be easy to do recursively, just with memoization, but it will be significantly different than our DFS. This will be more like recursive DP with memoization, and later we can change that to iterative DP, but only if we also do topological sort. But let's do the recursive DP. We have this. Let's say that I want a function. This function will return the paths, get paths starting from A, given a graph like that. Maybe I will also add memoization, but that I can do later. If A is equal n-1, then return a single path, just A. This means if we are at vertex 3, then what paths are there from 3 to 3? Well, there is just one path with single element. Otherwise, iterate over neighbors of A. And there are some my paths and I will return them. Those are, I'm looking for all paths starting at A and ending at n-1. This is what I want to find. This is what this function finds. Function get paths. I will put it just here. By the way, Monokai theme is nice, but if I change something into a comment, it's sadly hard to read because it becomes gray. How do we save paths, vectors iteratively? The same way we do it recursively. Are you asking about my current code? Okay, so from B, I ask about get paths. Starting from B, through the graph to the end. Poor highlighting color scheme. Yeah, just comments are stupid. His paths. Those are paths starting from B. And now for every such path, I want to say my paths dot pushback. And now A plus this path. This is pseudocode. This will not compile. I want to say that vertex A and then that long path. Just like here in a drawing, I said that if there is path 159 starting from 1, then there is path 0159, and this is a valid path that I should at the end return. How to do this? I think that's the easiest way. Path insert. Okay. Return get paths 0 graph. And here I might get time limit exceeded. Get rid of the old solution. I'm not removing that because maybe later I will need to refer to something. Submit, and I should get time limit exceeded, or maybe memory limit exceeded. No. I think I could create a test where this fails, where this is just too slow. Or maybe not, but runtime is much bigger. I think it will improve a lot if I do memoization, and that is map or unordered map. Oh, I don't even need that. Let's start with a map. From int to... move my face. No. From int to vector of int. This is what memo, whatever. This paths starting at this. if memo.count of a, if this map contains this key, dot, I don't know if they can run the same class multiple times, so I don't know if I can, if I need to like clear it between tests. Let's see. And because here key is only from 0 to n-1, yeah, you see it's a bit faster. I could just create this as an array or a vector, because key is only from 0 to n-1. This should just be vector of those elements, or whatever this is, with maybe some indication whether something was computed or not. Map is more convenient, so, and everybody should understand it because it's like dictionary in Python. And now this can be done iteratively if you find topological order first, because then you know in what order to go through elements. It's incorrect to do this logic going with vertices from 0 to n-1 on from 0 to n, or from n-1 to 0. It might seem tempting to say that there is n-1 at the end, then there is maybe n-2, and we will know that from n-2 there is edge like that, and so on, like with reverse order from n-1 down to 0. From every next vertex, I want to then compute what paths there are starting from this vertex. An issue might be that there is, for example, edge from 5 to 3. And then we first try to access 5, but we don't yet know paths coming out of 3. So it will be incorrect. What's the complexity of insert? Yeah, just like Mastran says, a map is log of n. Here it doesn't matter too much because this n is very small. So accessing map is log of n. But I try to here access map as log of n, but here anyway I have more operations. I copy some path. This is anyway number of edges going out of something times n. So this logarithm, it kind of disappears because it's anyway like n or maybe n squared plus log of n. This part is slow. Also, inserting at the beginning of vector is linear. If you want to really squeeze the time here, I think it's better to here use pushback or use another structure. At the very end, I can reverse every path. So instead of every time inserting at the beginning of vector, which is time consuming in C++, I could insert at the end with pushback, and that's just faster. It's constant time instead of linear. But other parts like pushbacking then a path, so saving this path is slow, so whatever. Okay, are you satisfied with the two non-trivial problems today? We want graph lectures. I think now the best place for any suggestions is my Discord server. Because also then people can vote on that, they can agree, disagree. Okay, this done. I need to remember about two things at the end. I need to rate somebody on Twitch, and I need to give you homework. I don't yet know how this homework will look like, what we will do next week at the start of the lesson, but I want to try. Also, next stream will be on Saturday, just after Codeforces round. And you can see that in my schedule. In Twitch there is even a link to my Google Calendar, you can import that. So yeah, Saturday after Codeforces round, I will just talk about my solutions from Codeforces. You don't want homework? If you don't solve homework, you cannot watch the stream. Sorry about that. You will need to like plug in the answer in order to unlock the Twitch stream. There will be a pop quiz. Exactly. Instead of streaming on twitch.tv/Errichto, I will stream on twitch.tv/answer to the previous problem. Yeah, I will solve one more problem. Number of visible points. Is that again the one with geometry? With the angles? I already rejected that. Yeah. Come on. Problem. I opened this problem before and I said that I don't want it. Can I suggest this one? You need to say a few words about your suggestion. If you just give me a link, what do I know about it? What if someone cheats on the homework? I don't know. Ban? We will run some cheat detector to find similarity of codes. Now, what I really think it will look like is that the idea is obviously to give you time to think about a non-easy problem. I don't think it makes a lot of sense to give homework with easy problems. Easy problems I can just solve during a stream. Yeah, to give you time to think about it, and you don't even need to code it. But I guess every week I can grab one or two codes. I would just get them via Discord, I think. It's not that I will... There are too many people in the chat. In Discord, I will take them from people whom I know or something. Just a random code to review. So your only reward for implementing it is that you have a chance of getting your code reviewed. Coming from C background, seeing C++ is like seeing a distant family. There are some syntax that are weird from C perspective. Half of the differences are STL. If you learn STL, you learn using vector, map, set, I think it will become much easier. Check this hard DP. Okay, I feel convinced. I didn't do DP today. No hard? Why no hard? Both these problems are hard. Oh, this one has a round number. And piles of stones arranged in a row. Move consists of merging exactly k consecutive piles into one. Limits are very small. Okay, let's do this problem. I will update the link. In Twitch, you can access a problem by typing !link. And let's think about this. I already know a solution. It will be very rare that dynamic programming on Leetcode will surprise me with anything. Let's take this example. There is a sequence 3, 2, 4, 1. For k equal to 2, I can take two consecutive values. I can merge them. Now new sequence would be 3, 6, 1. I take the sum of merged values. And the cost of that is the sum of merged values. So cost is 6. Then maybe I can decide to merge this as my second step. That would be of cost 7. And I have 3, 7. Finally, I will merge this with a cost of 10. I will get new number 10. Cost is 10. And here my total cost is 6, 7, and 10. In total, that's 23. Total cost, or maybe I will say answer, but that's not really answer because it isn't optimal. That's the total cost. In YouTube you don't have the link. You should, if you're watching on YouTube, you should open at least Twitch chat if you want to interact. Yeah, only consecutive piles indeed. I'm quite sure if we could take any subset, we would take smallest piles every time. But here we take consecutive, exactly k consecutive. That's even in bold, so that you wouldn't make a mistake. Okay, and if I was an interviewer, I wouldn't ask this in an interview, because if you don't know a similar problem, I would say you cannot solve this. I don't see how anybody could do that. Because solution will involve dynamic programming on intervals. And this is not something a normal programmer will come up with themselves. Sadly, this is what makes practicing for coding interviews very important and necessary, which I don't think it's ideal. Is in subsequence we can take smallest, just like Huffman encoding with priority queue. Why we can't do that? I think we can. Dynamic programming actually isn't asked in Facebook interviews. I think that Facebook banned all DP problems in interviews. And I like DP. I'm very good at dynamic programming, so for me, I would prefer if it's used. But for the good of all the programmers out there, I think it's good. No company uses it. Actually, no company. Other companies use it in interviews, unless you're talking about actually using it every day in job. For k equal to 2, this is called an optimal alphabetic binary code, and there is a linear time algorithm called Hutaker. I believe you. I believe you. What was that? I think something related is at coder DP problem slime. This thing. And it is possible to do this in some crazy complexity. And you need to Google to understand what's going on there. I will not cover it today. I'm just saying if somebody wants something more difficult, then this is a problem to do. And in submissions, you will find, if you sort submissions by running time, you will find something in linear time or quadratic, maybe quadratic. I don't remember. Anyway, this problem. Okay. Now we get some arbitrary k. And what do we do? Normally in DP, yeah, the runtime is unlogged. I think that's the same thing. I don't know. I didn't even now read the slimes. Oh yeah, that's the same thing. Sorry. I just remembered that it's similar. I didn't want to now spend time on reading this add coder statement. But yes, it's exactly what you said, that this is the same problem with k equal to 2. And I once spent like half an hour to understand what's going on with that fast algorithm. But I think it creates some kind of tree with strange order of leaves, and then it reads from this tree what needs to be done. This is what I roughly remember. But I will first explain to you, all my dear viewers, why I would think maybe during a contest this problem cannot be solved with dynamic programming. Because normally in dynamic programming, what happens is, let's say we go from left to right or something, and after we are done with prefix, we want to have some information about this prefix. But here the issue is that it isn't true that we deal with prefix and only then we deal with the right part. When there is, for example, knapsack problem, we can look at every next element looking from the left and decide whether we take it or not. DP will allow us to check all the possibilities in some better time complexity. So we cannot go from left to right. Then we should go through time. Maybe it's good to think about the whole sequence, and for example, if every time we could remove the first or last element and get some cost of it, then this could be done with dp, because always the remaining part is interval, and we can say that dp of interval from L to right, from left to right, so from this to this, there is some optimal cost of doing that. Makes sense. But our problem is more complicated. In our problem, if we go through time, if we consider what happens after a few steps of this process described in the statement, so if we already merged maybe this, if we already maybe merged this, then we maybe merged this new element with this one, assuming that k is equal to 2. Then there is exponential number of possible states. There's a big sequence, and every two next elements can be in particular merged already or not. So if we want in some way to represent after some number of operations dp of maybe the index of current operation, like now we do operation number 1, 2, or maybe here length of the remaining sequence, something. If you want to here keep as the second dimension state describing what moves are already done, there are exponentially many possible states. So how to solve this problem with dp? And sometimes we need one particular trick, and this trick is to consider the process backwards. This is also what I used. It wasn't necessary, but I used in our first problem today, when we moved from number to 0. Instead, I went from 0 to the number. I know that at the end, maybe this will be not that helpful, but it's related to what the solution is, I would say. Yeah, okay. At the end, I will have the sum of all numbers. Is that actually good? Maybe it's not a good explanation. We'll see. We'll see. I'm improvising. We know what happens at the end, that there is S. We can compute the sum of all elements, and this sum is S, then we know what is the look of the final sequence. But what can be the final sequence before that? The final sequence before that will consist of two elements, A, B. A will be sum of elements in some prefix, initially, maybe with colors. There's this, the sum of those elements is A, and the sum of those is B. There are n possibilities for this split. But what's important is that independently, A came from this interval, and B came from this interval. So going from the end, I have only n possibilities of what was there a moment before the very last situation, because there is a possible split point, n-1 possible split points. A is sum of numbers in some prefix, B is the remaining suffix. And what now? Yeah, I would like to know how to optimally solve this prefix, this interval. So I can kind of run recursively for this thing, and then again, I know that if I forget about everything else, and I just focus on this sub-problem, and this is what dynamic programming is, it solves sub-problems, then I know A, this is the sum of everything, and the last step, it merged two parts into A. Some left part and right part. And again, there are linear number of possibilities of the split, maybe 1 and 3 elements, maybe 2 and 2, and so on. There is some let's say, sum S1 and S2. Again, let's say lowercase a, lowercase b, and the sum of them is a. And again, a and b will come from some interval here, and I can focus on that subproblem. This is how you come up with the fact that it's important to solve problem for intervals of the initial sequence. And there are two ways to handle that. Iteratively from the very beginning, from small intervals maybe, or kind of recursively starting from the whole thing. So starting from the whole thing, I will do this. I still assume that k is equal to 2, because that's easier. Okay, let's say this is the initial sequence. I computed that the sum of all elements is 30, doesn't really matter. I can iterate over this. Before the last moment, what prefix was merged into a single element? Because before the last move, the sequence has two elements, maybe 13, 17. This 13, it came from merging some elements on the left, maybe those three elements. So I iterate over position I, this, let's say the last element taken to the left part, and I say that dp of 1n, the state is interval. I want to solve the problem for every subinterval of the given sequence, every range. This is equal to dp of 1 through I plus dp of I plus 1 n. How to optimally solve this, plus the sum of all elements. I know the sum, it's 30. I can compute that. And in general, I will do, let's say that there is a recursive function, and it gets the interval for which I want to compute the answer. I will say that int answer is initially infinity, iterate over the last element in the left part before the last move. Ans is minimized with dp of L comma I plus dp of I plus 1 R, this is the right interval, plus the sum of all elements. Here I iterate from, something is wrong with my mouse. I iterate up to R exclusive, from L to R minus 1, because for me I represents the last element of the left part. If this is L, this is R, and I want to split into two parts, like this, like that, or like that, then I, the last element of the right part, can be only those positions. For example, if it's here, then I have such a split. Then I plus 1 is the first of the next part. I don't want to make parts empty, because it's not that I have some empty stacks. Y plus sum, because it's said in the statement that making a move costs this much. If I had this, then everything would be 0. You can also think about it like this. You have some long sequence, doesn't matter what it is, but let's write down something. And DP problems are generally solved like this. This is a big sequence, and I don't know what is the answer. And there are so many possibilities that I cannot consider them. But let's say there is some black box, and if you provide any shorter sequence, any shorter subproblem, smaller subproblem to that black box, they will tell you the answer. If I ask that thing about subsequence 543, it will tell me, oh, optimally you can merge this into a single thing with total cost of 15. So what I'm going to do is I'm going to say, for sure, there are only several possibilities, like maybe I will say that this should be merged into a single thing, single item. The sum of values here will be 11, but what's the cost? What's the cost of getting this range to this single number? I ask the black box. This, all of that is merged to what? It will be merged to 19, but I ask the black box about the cost, and then to merge those into 30, I need to pay 30 because the statement said so. And that's exactly a query to a black box. Actually, I'm a black box myself. This is just recursive TP. Solving a smaller subproblem on the left part, right part, plus the sum, the cost of this merge, final merge of like here 11 and 19. And I consider that either this will be the first stack, the first heap of stones. What was that? Piles. So this prefix might become the first pile in the final step, or maybe this prefix, this, like n-1 possibilities. This is the last one. Of course, you need to add memoization, so that for every pair LR you would compute stuff only once. So you slap some map or two-dimensional array. Arrays are faster than maps because they have very fast lookup. Map is a complicated structure. An ordered map, so dictionary, is complicated as well. So that in the first line here you should say, if this state is already computed, the optimal answer for this interval, then return. Also, if L is equal R, return 0. This is infinity, so some int max will do the job. And I will just say that we return dp of 0, n-1. Obviously here we use sum, so I need to in some way pass the array stones as well, and here compute it. I can compute it with brute force here, like sum 0, iterate over our range, sum plus equal stones of I, as long as I have access to them. I could also pre-compute prefix sums and then be able to quickly say what is the sum in interval. Alright, so as long as I pass, for example, stones here, I'm good. Not to modify it by mistake, I will put constant. And yeah, the last step is memoization. But I think this should work, just it will be slow without memoization. What's wrong? n-1. Well. N is the number of piles. What is exclamation mark points doing? It's some kind of, I don't know, currency in Twitch, let's say. Okay. It would be surprising for me to see wrong answer. I expect time limit exceeded or memory limit exceeded. Okay, this is surprising. Expected -1. I solved the problem for k equal to 2. And now I consider that maybe bigger k should be your homework. What about that idea? I claim that this is, I think, a correct code for a k equal to 1. You can only merge k consecutive piles. Yeah. Of course, we need to do something different for k bigger than 2. And that something bigger is that, it isn't possible to iterate over possible splits in the I'm ahead out. It's not that difficult. Yes, it's a difficult problem, but it isn't impossible to do. Put k-1 dividers in the array. Exactly. But we shouldn't iterate over that because that's exponential number of possibilities. If this is the full array, then yes, if k is equal 4, then we need to put 3 dividers, splits. But now, think about it like that. There is some black box able to tell you cost of an interval. So now focus on this new problem of splitting a sequence optimally into intervals, and for each interval you have some cost. And that's some more standard DP where we go from left to right. And as we are at some position. We need to know how many intervals we already used. So I tell you that what's possible is that we will use dp here of I, the current position, the number of intervals used. That's my hint. And then we need to do some transitions. And yeah, so here goes my suggestion. This is one homework problem. Next week we will talk about this for general K. So there will be two homework problems. One is solve problem 1000. This is some hard DP. Also next week I will talk how I would do it iteratively, because this is recursive. You need to add memoization if you want to make it work even for k equal to memoization. But generally we can also do it iteratively. Then we go from short intervals to bigger ones, but then you just need to be careful with the order of for loops. You need to iterate over LR, and using shorter intervals compute this new one. So we'll get back to it. Okay. So homework number 1, a more difficult one, and homework number 2 will be it's not that I'm prepared, so for sure something not hard, maybe just medium. And yeah, this will also be announced in Discord in some way. If you have some questions, then also Discord. Some problem with high acceptance rate? Maybe. That's a complicated statement. High acceptance rate. Okay. Find valid matrix given row and column sums. Oh, I like this. Yep. Done. So homework is finish this and do that. This is easier. Next week, same time, there will be a stream and we will cover it. I will also copy paste in on YouTube, even though, as I said multiple times, I don't really follow YouTube chat during a stream. Can you explain tasks on Codeforces? I do that sometimes. For example, Saturdays are for Codeforces streams. What if we have already done the problems? It's not really school. I will not satisfy 100% of viewers by choosing proper problems. I'm just saying that next week I will talk about those two problems, and it might be beneficial for you to know them in advance. Try to solve them yourself. In particular, next week, because this is hard to finish, I will code the whole thing, both iteratively and recursively with memoization. I will try to get accepted. And maybe here we will talk just about, this is a constructive problem. We will talk about possible solutions maybe. There is no homework command yet. And I'm not aware of mashups in Leetcode. Homework, every ICPC original from 2018. That's if you're not busy. Like if you have a lot of time on your hands, then sure. Or just solve all AtCoder grant contests. AtCoder editorials are where AtCoder contests are. There is a button to go to editorial. Yep, that will be the end of the stream. Hope you like this. Join the Discord server, and there in the Errichto YouTube channel, this is a channel there for discussing streams, for discussing videos. There we can discuss also the format of this homework. I think there is something wrong with my washing machine, so I need to go. Or maybe it's neighbors. Okay, thank you everybody. See you on Saturday. On Saturday, after Code Forces, I will just talk about Code Forces solutions. Right. Oh yeah, right. Programming. Oh, we have Sonar Gonul again. That's a possibility. I don't want to write the same guy every day. Some pew pew and other stuff. If he speaks, then sure. Here you go. Join the Discord server. Thank you for watching.
Gifting gifts, always the best.
And have a nice day. Bye bye.
I'm just gonna put it on the same